Okay, this is part 2 for sections 1.2 and 1.3. We're going to start right here on this problem on the back of the first sheet of your notes. This is negative d minus 3 divided by 9 equals 2. So we're going to, let me rewrite that. I am going to take each side and multiply by negative 9. Okay? So that cancels that. And then I have d minus 3 equals negative 18. And then I'm going to add 3 to each side. So I have d equals negative 15. All right, let's go on to oh, there's one more. Let's put, let's do this next one. Okay, so I have to distribute first. So I have 5 times 2x is 10x. 5 times 6 is 30. And then I have 8x plus 48. So I'm going to subtract that 8x. So I'm left with 2x plus 30 equals 48. I'm going to subtract 30. So I have 2x equals 18. And when I divide by 2, I have x equals 9. Okay, so let's go back and look at the section that says types of equations. Okay, so if you have an equation with one solution, that means you're going to find one value for x. If you look at the problem, it's going to have different coefficients. I'll show you in a minute what it looks like. Different coefficients and the same or different constants. Let me give you an example. So one solution, so different coefficients, that's the number before the variable, and the same or different constants. So if I have 5k plus 3. So let me show you when I solve that. Oops, this should be 4k. Coefficients need to be different. This is 4. So when I subtract 4k from both sides, I have k plus 7 equals 3. And when I subtract 7, I have k equals negative 4. So that gives you one solution. Or you can have 5k plus 7 equals 4k plus 7. And let's see what happens. I'm going to subtract that 4k from both sides. And I have k plus 7 equals 7. And I'm going to subtract 7 from both sides. And I have k equals 0. So when your constants are the same, your answer is going to be 0. When they're different, you're going to have one solution. So that's one solution. So fill in that section for one solution. Okay, so let's erase this and go to no solution. That means when your equation doesn't have a solution, that means that no matter what you plug in for x, you're not gonna have equivalent equations. So it does happen that you have an equation that doesn't work. Where was I? I was here. So let's talk about no solution. Nothing will work. So when you have no solutions, your coefficients are the same, so same coefficients. And different constants. Here's an example for you. If I have 5k plus 8 equals 5k plus 7, when I get those variables on one side, they cancel out, right? And I'm left with 8 equals 7. And we know that on no planet anywhere does 8 equal 7. So if those two numbers are not equal, your answer is no solution. No solution. So you can see the pattern before you even solve it, and you can tell how many solutions you're going to have. So one last option for types of equations here. Before we move on to my favorite and yours, word problems, is infinitely many solutions. What that means is you can plug in any number and it would work. So when there are infinite solutions, you have the same coefficients and the same constants. So basically you have the same expression on both sides of the equal sign. I would have something like 5k plus 8 equals 5k plus 8. And let's look and see what happens. When I move that 5k over to be on one side, they're canceled, and you have 8 equals 8. And 8 always equals 8. So your answer is infinitely many solutions. All right, on to word problems. So my first one, oh, and look, there's Mrs. Surgeon. Mrs. Surgeon has a plant that was 4 inches tall when she purchased it, and it has grown 1.5 inches per month. Mr. Madigan bought the same plant, but it was only 2.5 inches when he bought it, but is growing 2 inches per month. When will the plants be the same height? So what you need to do is you need to construct two separate expressions on either side of the equal sign, and when you solve for x, that is when they'll be the same height. So here's Mrs. Surgeon. Hers grows 4.5 inches per month, and it started out at 4 inches tall. Mr. Madigan's started out at 2 inches, and his grow 2.5 inches per month. So let's solve for x here. So I'm going to move the variable to one side. I'm going to subtract 1.5 from both sides. So I have 4 equals 1, which would just be x, plus 2. I'm going to subtract 2 from both sides, and x is 2. Let's label that. So in 2 months, their plants will be the same height. Okay, moving on. Comcast charges $195 as a one-time setup fee to get Wi-Fi going in your house, and then $60 per month after that. AT&T charges $215 as a one-time setup fee, and then $50 per month after that. In how many months would it not matter which company was your internet provider? So again, we're going to set up those two expressions. One side is Comcast, one side is AT&T. So we have Comcast on this side, $195 plus $60 per month. And then we have AT&T on the other side, $215 to come in and set it up, plus $50 per month. So this is Comcast on this side, and this is AT&T on this side. Okay, let's get the variables over to one side. I'm going to subtract 50x. So I have 195 plus 10x equals 215. I'm going to subtract that 195. It'll let me write down there. So then I have 10x equals 20. I'm going to divide by 10. And again, just like the plant situation, it'll be 2 months' time before it won't matter which one you choose. All right, let's talk about consecutive integer problems. Number 3 says the sum of 3 consecutive means one after the other. So 1, 2, 3 are consecutive integers. 4, 5, 6, one after the other. So the sum of 3 consecutive integers is 132. What are the 3 integers? Here is how you set this up. X will be your first integer, and then x plus 1 is the next integer, and x plus 2 is the next integer, and they're all equal to 132. So this is the first one. This is the second one. And this is the third one. So now let's solve for x, and x will give you the first integer. So you have 1, 2, 3 x's, so 3x, and your constants together equal 3. That's all equal to 132. We're going to subtract 3 from both sides. So I have, 3x equals 129. And when I divide by 3, my first integer is 43. So if you take 43 and add 1, that's 44. And if you add 2, 43, that's 45. So if you add these all together, they equal 32, and they're consecutive, 43, 44, 45. So now we're going to talk about odd integers. So odd is 1, 3, 5. If you're going from 1 to 3, you're adding 2 this time instead of 1. So here's my first integer. Then my second one, you're going to add 2. And to get to my third integer, I'm going to add 4. The total of those together is 57. So now we're going to solve for x. 1, 2, 3 x's plus 6 equals 57. I'm going to subtract 6. So I have 3x equals 51. When I divide by 3, my first integer is 17. So now the odd ones, 17 plus 2 is 19. 19 plus 2 is 21. When you add those up, those are 57. Couple more here. Why don't you try number 5 on your own? And let's go to real-world applications. 4 friends buy tickets for 2 concerts on consecutive nights. They use a $5 off coupon for each ticket. They pay a total of $416 for 8 tickets. Write and solve an equation to find the original price of the tickets. Okay, so here's my equation. There are 4 friends and they are going twice. So I need 8, and then they pay for the ticket but subtract 5 for the coupon on each ticket. Okay? And then together that equals 416. So 8 times x is 8x. 8 times 5 is negative 40. Now I'm going to add 40 to each. So 8x equals 456. And I'm going to divide by 8. So each ticket was $57.